Hi everyone, we're looking at quadratic equations. First question, what's a quadratic equation? Well, that's one that looks like this. It's got an x squared in it, minus 5x, say, plus 6. That's just one example, but it has to have an x squared in it. We've seen quadratic expressions before. What makes it an equation is that it's equal to something. Okay, you've got one side is equal to another side. So this whole thing is equal to 0. Quadratic equations have two solutions. So this one, for example, 2 is an answer because 2 squared minus 5 times 2 plus 6 is the same as 4 take away 10 plus 6 is 0. Or 3 is also a solution. If you plug in 3 squared, take away 5 times 3 plus 6, you get 9 minus 15 plus 6, and that's 0 as well. So quadratic equations usually have two solutions and have an x squared term in them. Now, how did I get 2 and 3 there? I'm going to answer that in a minute's time, but first we need to do a bit of revision. How do you factorize a quadratic expression? So I'm going to show you two methods here. One, in both cases, we're going to call this number here the guide number and this number here the target number. So what you do first is you factorize the guide numbers. So say 6 can be factorized as 1 times 6, 2 times 3. When you get to 1, 2, you can try 3, but sure, you've already got 3 times 2. So once you meet a number you've already used, you know you've done all the factors. That's obvious for 6, but for higher numbers, that's a useful thing to know. Don't forget the -1 times -6, -2 times -3 as well, because the target is, we should be able to add two of these numbers together to get the target. So that's 7. 2 and 3 is 5, but we want -5. So it's -2 and -3. That's what gives us our target. And then we come along and we break up this expression. We say, well, x squared minus 5x I can write as -2x minus 3x plus 6. What do we do next? You say, factorize this by parts. You've got a common factor of x here, times x minus 2. Now here you've got a common factor of 3, but you always take this sign. So if that's negative, you take -3. That middle sign, you always take it. -3 times x, and then -3 times -2 gives plus 6. So this whole thing can be factorized as x minus 2 times x minus 3. And I often just mention factorizing just means rewriting a number. So we factorize 6 up here as 2 times 3. It's rewriting the expression as one thing multiplied by another. The multiplication there is key when you're factorizing. Some of you might have used the array method to factorize these, where you'd say, well, I'm multiplying something by something, and I'm getting x squared minus 5x plus 6. The x squared always comes out of that box, and the constant term, the plus 6, always comes out of that box. I need an x and an x to make an x squared. And again, my guide numbers up here tell me -2 and -3 is going to get me -2x and -3x, which adds up to -5x, which is what I want. So you might have factorized that way and said that's x minus 3 times x minus 2. Okay, these ones are manageable enough when it's a 1x squared. This example here, where it's a 5x squared, is a little bit trickier. With these ones, the guide number is that first number multiplied by that last number. So it's a guide number of 30 is what we have here. Target is still this middle number, -13 in this case. Okay, now that actually works with our last example because that's a 1x squared. So 1 multiplied by 6 gives 6. So you could have said, well, the guide is really 1 multiplied by 6, and that's how I got this 6 here. So let's factorize our guide here. Okay, that happened quickly. -3 times -10 there gives 30. And if I add -3 and -10 together, I get -13. So that's my target. So what do I do next? I say 5x squared minus 3x minus 10x plus 6. So I've broken that -13 up. I've said these are the same, but I've broken -13 up into -3x minus 10x. What's my common factor here? X times 5x minus 3. Take away what's common here. So you always stick with this minus here. You always hold on to that. Common there is a factor of 2 times 5x, and then -2 by -3 gives plus 6. And you should always end up with the same thing in these two brackets when you're factorizing like this. So we get x minus 2 multiplied by this common factor of 5x minus 3. Okay, the same approach using the array method. Well, you know you're going to have 5x squared here, and you're going to have a plus 6 down here. To get a 5x squared, thankfully 5 is prime, so that's 5x times x. You don't need to worry too much about that one. And to get a 6, you're going to come back up and look at your guide numbers. Now, you don't put your guide numbers in here this time, but it's still 5x squared minus 13x plus 6. Your minus 13 is still coming from these two squares. So you know you need to get a minus 3 and a minus 10 together. Okay, now 5 multiplied by nothing will give minus 3. So that minus 10x has to go there, and the minus 3x has to go there. Okay, so you're still coming up to your guide numbers. So even when you use this method, you still need to factorize your guide number. Minus 3 minus 10 is minus 13. So what had to go here? 5x multiplied by minus 2 gives minus 10x. What had to go up here? Well, x multiplied by minus 3 gives minus 3x. Did that work? Minus 2 by minus 3 gives plus 6. So yes, it did. This thing factorizes as x minus 2 multiplied by 5x minus 3. And by the way, it doesn't matter if you did them the other way around. It's the same thing. 5x minus 3 multiplied by x minus 2 is also a correct answer. Just like 20 is the same as 5 times 4 or 4 times 5. The order doesn't actually matter. Okay, so coming back to quadratic equations, that's when you have this equals 0 and you want to solve it. You want to find the two values of x that satisfy this. And as we said, we know they're 2 and 3 already. But looking back over here, we've already factorized that expression. Okay, it's x minus 2 times x minus 3. So let's write that down here. X minus 2 multiplied by x minus 3 equals 0. Now, if you have 0 as an answer to a multiplication problem, as in if you have something multiplied by something equals 0, well, one of those input numbers, either this one is 0 or the other one is 0. That has to be the case. So once you get here, you can say, well, then either x minus 2 is 0 or x minus 3 is 0. Okay, and then moving that 2 over, you get x equals 2, or 2 minus 2 is 0, or moving that 3 over, you get x equals 3. So these are our two possible solutions to this quadratic equation, and they're the two solutions that we saw right at the start of the video here. 2 and 3 were solutions to that equation there. What about this next one? 5x squared minus 13x plus 6. What if I make that into an equation by saying 5x squared minus 13x plus 6 equals 0? Well, I know that factorizes as x minus 2 times 5x minus 3. Okay, and now according to my rule, one of those inputs, either this number or this number, one of the things I'm multiplying has to equal 0. So either x minus 2 equals 0, which will mean x equals 2, or 5x minus 3 equals 0, which means 5x will equal 3, and x is 3 divided by 5. So there's two solutions there. That you could write that as 0.6 if you wanted. 2, plug that in. 5 times 2 squared is 4. So that's 20. Take away 3 times 2, take away 26, makes negative 6, plus 6 gives 0. So 2 is one solution. You can plug in on your calculator 0.6 there and get another solution as well. Okay, one more example here. This is a quadratic equation. So we want to find two solutions, x equals something and x equals something else. And we're going to do it start to finish. Okay, I'll just point out that because this is negative 14, it means it's easy enough to make mistakes with the signs. I see students make mistakes with the signs on this all the time. So start off, what's our guide? It's going to be 3 multiplied by negative 14. Okay, so that's negative 42 is our guide. Right, so let's factorize that. 1 times negative 42. 2 times negative 21, 3 times negative 3 negative 42, 10, 14 times. 4 doesn't go into 42, 5 doesn't go into 42, 6 times negative 7 And then when you get to 7, well, you've just kind of used 7. So you know now you've got a full list of all the factors, except that you've only got half of them. Okay, the other half are -1 times 42, -2 times 21, -3 times 14, and -6 times +7. Okay, which pair of them will give us 19 if I put them together? Plus 19, okay, that's going to give me -19, but -2 and 21, that gives me plus 19. So let's go 3x squared plus 21x minus 2x. Okay, that's breaking up that 19 into 21, take away 2, minus 14. Okay, so all I've done is rewritten my equation, but now I'm able to factorize it. But by the way, if you said minus 2x plus 21x, that's absolutely fine. That order doesn't matter. What's common here? We've got a common factor of 3x multiplied by x plus 7. 3x squared, 3x times 7 is 21x. Always take this middle sign, minus 2 times, okay, 2 is a common factor here, and x. Now, minus 2 times plus 7 makes minus 14. Okay, so that's it factorized. Our next line, sorry, not factorized fully, sorry, our next line says 3x minus 2 is one factor, multiplied by x plus 7, there is a common factor. Okay, because look what we're getting. If you multiply that out, it's x plus 7 multiplied by 3x, which is this bit, and then x plus 7 multiplied by -2, which is this bit. Okay, from here, we know if we're getting 0 as an answer to a multiplication problem, then either the first part, 3x minus 2 equals 0, or the second part, x plus 7 equals 0. So in this case, you get 3x equals 2, and x is 2/3. And in this case, x is minus 7. So those are our two solutions. Okay, you might try these 3 questions yourself for class tomorrow. There's the solutions there on the right-hand side. For that first one, that second one here, and that third one there. Okay, so try factorize and solve those 3 equations yourself. Show how you get these 3 solutions. Talk to you tomorrow. Bye-bye.